Welcome to lecture L2D of Computer Programming Fundamentals. Computer Programming Languages, the 1960s. The 1960s introduced the computer programming languages that set the stage for the computer programming languages that dominate today. Without the computer programming languages of the 1960s, today's dominant computer programming languages of Java, Visual Basic.NET, and C# would not exist. The 1960s set the stage for computer programming languages of today. Simula, although developed as a computer programming language to process simulations, was the first computer programming language to introduce the computer programming language object-oriented paradigm. As such, computer programming languages of Visual Basic, Java, and C# owe much to Simula. Snowball was a computer programming language developed to process strings and patterns. This led to computer programming languages such as Perl. APL's enhanced array processing capabilities led to the development of commercial programming packages like MATLAB. BASIC has evolved significantly from an interpretive microcomputer programming language to a computer programming language based on the computer programming language object-oriented paradigm, such as Visual Basic.NET. PL1 set the stage for combining business and scientific computer programming functions into one common computer programming language. And finally, the computer programming language B led to the computer programming language C, a computer programming language for both low and high-level computer program development. Thus, the C computer programming language was used to develop application solutions as well as operating systems. For example, the Unix operating system is written in the C computer programming language. Simula is a name for two simulation computer programming languages, namely Simula 1 and Simula 67. Originally developed in the 1960s at the Norwegian Computing Center in Oslo by Ole Johan Dahl and Kristen Nygaard. Simula is syntactically a superset of Algol 60. Simula 67 first introduced objects, classes, and subclasses. Simula 67 also introduced virtual methods, coroutines, and discrete event simulation. As such, Simula is considered the first computer programming language based on the computer programming language object-oriented paradigm. As its name implies, Simula was designed for running computer programming simulations. Thus, the simulation domain provided the framework for computer programming languages based on the computer programming language object-oriented paradigm, the computer programming language paradigm dominant today. Simula has been used for a wide range of computer application solutions. For example, simulating very large systems integration designs, simulating process modeling, simulating communication protocols, and simulating processing algorithms. Thus, the influence of Simula on the computer programming languages to follow is often understated. In fact, Simula-type objects have been re-implemented in C++, Java, Visual Basic, and C#. Note that Barney Soustrup has acknowledged that Simula 67 was the greatest influence on him to develop C++. C++ combined the productivity enhancements featured by Simula to the raw computational speed offered by lower-level computer programming languages like BCPL. Snowball, short for string-oriented and symbolic language, includes a series of computer programming languages developed between 1962 and 1967, culminating with Snowball 4. Snowball was developed at AT&T Bell Laboratories by David J. Farber, Ralph E. Griswold, and Ivan B. Polonsky. Snowball 4 was one of a number of text string-oriented computer programming languages developed during the 1950s and 1960s. Other text string-oriented computer programming languages developed during that period include Commit and Track. Snowball 4 stands apart from most computer programming languages by having patterns as first-class data types. First-class data types can be manipulated in many ways. First-class data types also provide operators for pattern concatenation and alternation. As such, strings generated during program execution can themselves be treated as computer programs. Snowball 4 was widely taught in larger U.S. universities in the late 1960s and early 1970s. Because of these enhanced string processing capabilities, Snowball 4 was widely used in the 1970s and 1980s as a text manipulation language. Snowball 4's use has faded in recent years in favor of newer computer programming languages. Newer computer programming languages such as awk and Perl, where Perl and awk have made string manipulation by means of regular expressions more fashionable. Snowball 4 patterns subsume Backus normal form grammars. Backus normal form grammars are equivalent to context-free grammars. As such, Backus normal form grammars are more powerful than regular expressions, because regular expressions, unlike Snowball 4 patterns, cannot be processed recursively. Thus, recursive processing initially gave Snowball patterns a distinct computational advantage over Perl. However, this computational advantage of Snowball 4 over Perl no longer exists, as Perl now processes regular expressions recursively. One of the designers of Snowball, Ralph Griswold, designed successors to Snowball 4 called SL5 and Icon. These successors combined the backtracking of Snowball 4 pattern matching with the more standard ALGOL-like structuring. The initial Snowball language was created as a tool to be used to manipulate symbolic polynomials. Snowball initially was written in an assembly computer programming language for the IBM 790. Oddly enough, this led to the processing of patterns that influenced the computer programming languages to follow in the future. Those computer programming languages based on the computer programming object-oriented paradigm. Those computer programming languages dominate today. APL, short for a programming language, was developed originally in 1964 at IBM. APL is an interactive, array-oriented computer programming language, combined with an integrated development environment. APL is available from a number of commercial and non-commercial vendors. APL runs on most computer platforms. The APL computer programming language is based on a mathematical notation developed by Kenneth E. Iverson. APL features special attributes for the design and specifications of digital computing systems, special attributes focusing on both computer hardware and system software. APL includes a combination of unique and relatively uncommon features. Uncommon features that appeal specially to expert computer programmers that make APL an extremely productive computer programming language. First, APL is concise because it utilizes symbols rather than words for applying functions to entire arrays without having to use loops. In other words, APL applies functions to arrays as other computer programming languages would apply functions to scalars. Second, APL is focused on emphasizing the expression of algorithms independently of the computer machine architecture or operating system hosting the APL computer programming language. As such, APL is highly portable because it facilitates problem solving at a high level of abstraction. I used APL back in the 1980s in a time-sharing environment. I was amazed at its power. It processed arrays like other computer programming languages process scalars. Although learning the expanded symbols along with the special APL keyboard presented a challenge, APL sure provided a new computer programming experience, a very powerful and productive computer programming experience. As such, APL became instrumental for its use in scientific, actuarial, statistical, and financial applications. These applications provided a problem-solving tool directly to user practitioners to solve their own problems. Computer programmers could also develop commercial applications in APL for layman users. Thus, APL was an important influence for the future development of spreadsheets, functional programming, and computer math packages. For example, computer math packages of Mathematica and MATLAB owe their existence to APL. BASIC is a family of general-purpose, high-level computer programming languages whose design philosophy emphasizes ease of use. BASIC, an acronym for Beginner's All-Purpose Symbolic Instruction Code. The original BASIC was designed in 1964 by John George Kemeny and Thomas Eugene Kurtz at Dartmouth College. Dartmouth BASIC was used to provide computer programming instruction to non-computer science students. I first used BASIC in the late 1960s in a time-sharing environment, using a teletype dumb terminal that punched source code onto punched paper tape. Ironically, I also remember a movie portraying Bill Gates, Steve Ballmer, and Paul Allen sitting in their Harvard dorm room creating a BASIC program on punched paper tape. Later I used True Basic, which was a version of BASIC developed by a company formed by Kemeny and Kurtz, a company that resided in Hanover, New Hampshire. During the 1960s, nearly all application solutions were developed based on custom software. As such, the development of application solutions was something only reserved for computer scientists and mathematicians. Fortunately, the BASIC computer programming language and its variants became widespread in the late 1970s and 1980s, especially on microcomputers where it became a standard feature. In fact, BASIC was often part of the firmware of the microcomputer. I have vivid memories of IBM BASIC A, TRS BASIC, True Basic, Turbo Basic, GW Basic, etc. By the way, GW stands for Gates William. As such, an easy-to-learn general-purpose computer programming language such as BASIC was now made available on these early personal computers. This, for the first time, allowed small business owners to develop their own custom application solutions. BASIC was thus responsible for fostering a widespread use of these personal computers for businesses of all types and sizes. Thus, businesses that previously did not have access to computing technology now had the capability to develop their own application solutions to support their businesses. My first class in 1980, when I began teaching as an adjunct professor, was introducing the personal computer and its impact on businesses to an MBA Saturday morning class. I used an Apple II using Apple Basic to demonstrate how computers could impact businesses. No surprise that BASIC remains popular today. Numerous dialects and even new computer programming languages have been influenced by BASIC. The best example being Microsoft Visual Basic. In fact, in 2006, 59% of developers for the .NET framework use Visual Basic.NET as their only computer programming language. BASIC has become a truly remarkable general-purpose computer programming language. The computer programming language has evolved from an interpretive procedural computer programming language to a compiled, link-edited, object-oriented computer programming language. BASIC now operates in a visual rapid application development environment a visual rapid application development environment where the source code is generated by the design of the graphical user interface. BASIC sure has come a long way from that Saturday morning MBA class. PL1 is short for Programming Language 1. PL1 is a procedural imperative computer programming language. PL1 was designed for both scientific and business computer programming application solutions. Like the C computer programming language, the PL1 computer programming language has been used by a wide range of organizations. A wide range of organizations including various academic, commercial, and industrial organizations. The PL1 computer programming language was introduced in 1964. Because the syntax of the PL1 computer programming language is English-like, PL1 is well suited for describing complex data formats. Initially in the 1950s and early 1960s, business and scientific users developed computer programming application solutions for different computer machine architectures. No surprise that different computer programming languages were used for scientific and business computer programming application solutions. During this time, business users were moving toward computer programming application solutions developed in COBOL, while scientific users developed computer programming application solutions in Fortran and ALGOL. The IBM System 360 series, announced in 1964, was designed as a common machine architecture for both scientific and business users. The IBM 360 superseded all existing IBM computer machine architectures. As such, IBM wanted a single computer programming language for all users, namely scientific users as well as business users, that would operate on the IBM System series of computers. In fact, my first computer programming application solution that I developed ran on an IBM 360 Model 30 computer. Although my computer programming application was for business users, scientific users also used the same computer. IBM hoped that the Fortran computer programming language could be extended to include the features included by commercial computer programmers. In 1963, a committee was formed and composed of IBM and the IBM Scientific Users Group. The committee proposed extensions to the Fortran computer programming language to adapt the computer programming language for the development of both scientific and business computer programming application solutions. Unfortunately, the extensions could not be implemented for the Fortran computer programming language. As such, the approach was abandoned in favor of the development of a new computer programming language. This new computer programming language was named NPL for a new programming language. However, the NPL acronym conflicted with that of the UK's National Physical Laboratory. Thus, NPL became PL1. Control of the PL1 computer programming language was vested initially in IBM's New York Computer Programming Center, later moved to the IBM UK laboratory at Hursley. The Share and Guide user groups were involved in extending the computer programming language. Guide serving the IBM's business user group, while Share served the scientific user group. This combined scientific and business user involvement led to the formal definition of PL1. In 1967, a complete specification for the PL1 computer programming language was developed, a computer programming language that could be used by both scientific and business users. My first application was classified as a business application because it was used to allocate taxes to the various states that the pipeline traversed. But in order to allocate the taxes, it had to measure the natural gas flow in the pipeline. So I guess you might classify the computer programming application solution as a hybrid business scientific computer programming application solution. A hybrid business scientific computer programming application solution processed on a computer based on IBM's common computer machine architecture, namely the IBM 360 series of computer machines. B is a computer programming language that was developed at Bell Labs in 1969. B is almost extinct as it was replaced with the C computer programming language. B was mostly the work of Ken Thompson with contributions from Dennis Ritchie. Ken Thompson wrote B basing it mainly on the BCPL computer programming language. BCPL was used to write the original Unix operating system as part of the Multics project. B was essentially a stripped-down version of BCPL, as components that Thompson felt he could do without were stripped out of BCPL. This allowed B to fit within the memory capacity of the mini-computers. Mini-computers targeted to house the B computer programming language. B also included some changes made to suit Thompson's preferences. Like BCPL, B had only one data type. Most operators treated this one data type as an integer, while other operators treated the data type as a memory address. However, in many other ways, the B computer programming language looked a lot like an early version of the C computer programming language. A few library functions existed in the B computer programming language, including some that vaguely resemble functions from the standard I/O library of the C computer programming language. Early implementations of the B computer programming language were for the DEC PDP-7 and PDP-11 mini-computers, which ran the early Unix operating system. Ritchie wrote a B compiler using TMG, which produced machine code for the PDP-11. In 1970, Ritchie took over maintenance of the B computer programming language. Starting in 1971, Ritchie made changes to the B computer programming language. The B compiler was extended to produce machine code that added data typing for variables. During 1971 and 1972, B evolved into New B and then to the C computer programming language. A preprocessor was added in 1972 at the urging of Alan Snyder. This effort led to the development of the Unix kernel for the PDP-11. The Unix kernel was rewritten in the C computer programming language. This culminated the B computer programming language's contribution to the progressive evolution of computer programming languages, namely the emergence of the C computer programming language that could be used for the development of computer programming application solutions as well as operating systems.